Cool, we're good. Hello. End of the day, nearly. Cool. So, show of hands quick. Who's used Angular before? Amazing. I was expecting like 3 people, but yes, make my talk much easier. Cool. Yeah, so we're going to be talking Angular 2, but more importantly, instead of just showing you a bunch of code and going, yeah, here's Angular 2, we're actually going to learn about some of the design fundamentals behind Angular 2. So we're going to look at component architecture and a load of other funky stuff. So my name is Todd Motto. You can tweet me some abuse or some nice things or even questions after this. That's my Twitter handle, obviously. So the talk overview, we're going to be looking at, there's a big long list, so I'm hopefully going to fit this in. Where's my, have I got a timer somewhere? No. So yeah, we're going to look at component architecture. And then a lot of people kind of say, oh yeah, are you using component architecture yet? And you're like, yeah, I think so. But not a lot of people actually understand component architecture. So we're going to look at what kind of that means. Then we're going to look at the types of components in a component architecture. Then we're going to look at one-way data flow in Angular, believe it or not. And then we're going to look at some Angular 2 implementation. We're going to sort of run through a load of code. And then this is pretty cool, is how Angular kind of sits on top of, Angular 2 sits on top of the web platform. It does this through web component integration, so we'll show you some really cool stuff. Then we'll learn sort of like the basics of how we apply these concepts in the first couple of bullet points to an Angular 2 application. So we'll do that through bootstrapping, which is a process of like kickstarting an Angular application. Then we'll look at components, and then routing, or routing if you're from America. And then server-side and web worker rendering. Sadly, I don't have any code to demo for server-side and web worker, because if you've been following Angular 2, it breaks a lot, and I couldn't find the right piece that was updated. So for those who aren't Angular developers or have never heard of AngularJS, AngularJS was it was born in 2009. It's built by Google. And Angular 2 is in development at the moment. So it's just come out of beta stage. It's now in a release candidate, I think number 1. So it's a successor to Angular 1. It's a complete rewrite. They've kind of thrown it out, and, well, not thrown it out, started a blank slate, and then built it in a completely different way. So it's cutting edge. It's future focused. There's a lot of stuff that is in the browser or will be in the browser that are behind flags and all these latest tools which Angular is kind of building ahead. So if you have looked at Angular 2 and gone, you know, this doesn't work in any browser, it's not what Google's goal is. So they're kind of aiming ahead, much like they did with Angular 1. So it sits on top of the web platform, uses component-based architecture. And this is really interesting. So we have, it's obviously for web, otherwise we wouldn't be at the web conference. A mobile web. So one of the performance things that they had in mind was to make it work fast on the mobile web, 60 frames per second, unless you write terrible code. And what's also interesting is, we'll actually dive into this a little bit deeper, but where you build traditional applications, you write HTML, CSS, and you kind of bundle them all together and ship it off to the client. Whereas Angular have abstracted the way that we write Java, that we kind of create components. So we no longer manipulate the raw DOM nodes. So Angular have abstracted this for us, which enables us to basically compile Angular code to native and mobile desktop applications. Namely, what is going on? I didn't do that. It's a ghost. Those are my screenshots. Cool. Snip that bit out. So let me zoom in a bit, because this is a bit. There we go. Think of Angular 2 as a web platform, not like a framework. There's like all this, there's a framework coming out every single week. So when you start to think of Angular 2 as a framework, every kind of web API and all the brand new APIs like service workers, web workers, all these kind of things, Angular kind of looks at the bigger picture and sits on top of them all. So we can build all these applications that basically work everywhere. So what kind of makes up an Angular 2 app? It was pretty big. If you've done a hello world with Angular 2, you get like, it's almost 2 megabyte for initial load. But after this talk, you'll kind of go, okay, I understand. So they've broken it down into core, loads of different modules. They did this at ngconf a couple of weeks back, a week or two ago. So this kind of makes up that Angular is the core of Angular and all these other modules that we can pull in and use. We also have a heavy use of components. So traditionally, when we all started building like web applications, we would have like a router and then a view, and that view would just contain like 2,000 lines of code, and you kind of finish the project and think, what have I done? So by using components, we can make them a lot better and more structured applications, which sits in nicely with one-way data flow. There was a talk yesterday on RxJS, so we're not actually covering that, so you can rest easy. And TypeScript. Does anyone like TypeScript in here? A couple of people? More than I thought. Very brave. And then the CLI, so command line interface, which the Angular team are working on to basically make all the boilerplate and setup a lot faster, a lot easier. Then we've got the template compiler. So it's not kind of writing HTML, CSS, and styles and classes. It's try and think of every template that you do, it's going to be compiled by Angular. So try and think of it as a compiler, not just some sort of thing that you add attributes to that do cool things. Dependency injection and zones. We're not actually going to touch these, but this is kind of two of the main pieces of Angular. Zones are how Angular does like all the change detection and all these kind of things. And dependency injection is where we can, if you're a back-end programmer or have previously done back-end programming, dependency injection is like asking for a dependency. In Angular 1, you do that via, if you have a controller, you can ask for a scope object, for example. So this is the fun part where I did some amazing drawings. So if you imagine this is Gmail, for example, if anybody's not used Gmail, create an account now and follow along. So if you imagine component architecture in this kind of diagram, so we have a search, we have a list, and then we have a chat. So we could have a chat component, which is obviously going to have more components inside, and then we have a list on the other side, which could be where you have like create a new message, inbox, drafts, spam, all that kind of thing. And then at the top of Gmail, you've got that search component. Then you've got the view container, and if you don't know what view is, in web applications, a view is where we can dynamically change. So if you're in Gmail, for example, and you've got your list of email messages, you click on one of them, it then it basically destroys that middle container, but keeps the outside consistent. So that's our view container. We can swap things in and out. We can change the URL and our templates accordingly. So with a component architecture, we can start to break down things of what we would actually want. So yeah, we have a chat component in the sidebar. So we're not obviously going to start writing a web application, make it really complex. We're going to break things down. We need to start thinking about them. If that goes again, please just wave, because I can only see my screen. So inside the chat, we might have a chat profile. If you used Google Hangouts, you get your sort of little profile picture, your online status. You could be online, offline. Then we have a chat list where we can see all of our friends that we can click on, and we can then open a new conversation. Then we also have a chat search. I'm getting scared now. Where we can type someone's name. So you could type Todd, click on me if you wanted to, and then you could talk to me. So how do we think of this? Very simple with component architecture. We have a root component. Then we have a child component, and then a child component. Now, this is the kind of the high level of a component architecture in this sense. So when we actually start building, we need to start thinking of what roles do these components have. So as a base element in our application, we're going to use a chat element. So this is a custom element, part of the web component spec. Inside that, we have chat-profile. It's another custom element. We have chat-list, and then chat-search. So this might look super easy, but when you start to build with Angular, and even in Angular 1, if you're obviously still building with Angular 1 or any other framework, component architecture is not tied to a framework. So we can start thinking about these as high-level elements and then start going down a little bit further. So we'll look at this one, and just to give you an example of like the flow of the tree, we have chat at the top, and then these little arrows coming off, chat profile, chat list, chat search. So usually these arrows will indicate some kind of data flow that is being passed down. So now you kind of get component architecture from a very high level. There are actually different types of components. So obviously, when we all started off building websites or web apps, we make a complete mess of things. So now we can not make a mess of things and actually think about the types of components that we're creating. So you may have heard the word stateless component, or we'll give it some other names in a second. So we've got a stateless component, a stateful component, so it has state, and then a rooted component. So these are basically the three types of components that we'll be building with on the web. And we'll actually dive a little bit deeper into these next, and then how we can apply them to Angular 2. So with a stateless component, and I'll go to the bottom line first, you might have heard it as a DOM component, presentational component, or a stateless component. So what do these do? They have defined inputs and outputs, so you can have a component, you can pass some data into it, it can do something with that data, and then pass it back up. So it takes the data via an input, does something with the data, passes it back up via an output. So we call the way that we pass an input, we use property binding, and then we use events to basically pass the data back up. So that's a stateless component. And you'll notice it hasn't made an XHR request to the back end. It hasn't actually gone and fetched some data. It's literally just passed some data. Whereas a stateful component communicates with services and states. So it could be quite similar in the sense it has a template, it has other things that might look like a stateless template component. However, a stateful component doesn't directly mutate the state. So if you have like a backend, and I put a little red box here if you compare it with the previous one. So the red box is our service, it's the backend, it goes and fetches some data. And if you look at bullet 3, we've got render child components. So if you try and think about this in our chat component that we just looked at, the chat was the root element, which could be a stateful component. It could go and fetch the list of chats. It then has child components that it renders. And then we can pass that data down into stateless components. They can then mutate the data and then pass it back up. So they don't contain stateless components, and stateful fetch the state. Then we have something called a rooted component, which is kind of like a more advanced stateful component. So we probably know these as views. So if you've got a Gmail, for instance, you've got a view in the middle. These are basically just stateful components, but they have root definitions. So where you set up your routing, you can then navigate to a specific view in the URL, which goes and fetches the template. But you don't want to just change the URL and fetch the template. You want to actually go and get the data associated with it. So it goes and gets the state associated with a particular route. So these are typically characteristics of a rooted component. One-way data flow. Here's just like a more cool diagram. So if you imagine you've got a service, if you've not heard the term of a service, it's just some kind of function or some implementation that allows us to communicate with the back end. You could pass in parameters from the URL, for instance, like a user ID, and go and fetch some data associated with that particular route. So if we've logged into Gmail, for example, we might want to go and get our list of emails, which we bring back from the service, and we actually inject it into a component. And the way that we do this is called property binding. So if you've used Angular or React or any of these other things, in React you have this.props. In Angular you bind to custom HTML elements. So here we bind to custom HTML props, pass the data via one-way data binding. So if you've used Angular 1, one-way data binding is now in Angular 1. Everything before that was two-way data binding, and then we end up with a bit of a mess. So the initial component that we pass or is given the data is usually a stateful component, which can then pass down to stateless components to then render maybe more stateless components. It's up to you, obviously. This is just a simple diagram of how to render a DOM hierarchy. Then, if we wanted to pass the data back up, because we like a unidirectional data flow, as the Facebook team, we built React, kind of proved that is awesome and more awesome than Angular's two-way data binding. So we now have one-way data binding in Angular 10 years later. So how do we get the data back up? We could obviously use something like Redux or NGRX, which is an Angular 2 implementation of kind of Redux bindings. But to do it raw with just components, we use event binding. So what does event binding kind of mean? Let's imagine this middle tier. I think I've got a light. It doesn't work. Laser. So if you imagine the middle three components, they might have a function that they delegate to the child component, the child of that component. When that component manipulates that data, it can then call that parent function, so it can then pass that information back up to the parent. If you look at the second bullet, we've got mutate isolate data inside a child component. I've used the word isolate. It kind of comes from Angular, but essentially, if you're using something like immutable JS, you'll notice performance gains by, instead of mutating an existing object or an array or a collection, you can make a clone of that collection and then mutate it and then send the clone back and then rebind it. So you're kind of treating the parent data as immutable. And we can do this in Angular 1 and Angular 2. So then we continue passing it back up. We can pass it up to the child component, which might delegate another function. And then we can send it off to the service. For instance, if a user has ticked the checkbox in Gmail, that then might pass an event back up to the parent, which you can then register the email that was clicked, and then you might have a function on the parent, which is our little trash can icon. Press that, and it deletes it, because it's already been given that information. So a couple of things. Data down, events up. It's as simple as that in one-way data flow. The interesting thing, which kind of clicked for me, because I've been using Angular for years and years now, and we all use two-way data binding and create a bit of a mess. But if you think about a component as an API, like we've all used like jQuery plugins and other JavaScript plugins, and you'll have like a configuration object where you can pass particular properties to and say, yeah, display this true. Then you might have like on change and then a function. So if you imagine translating that into a type of component, that your component is just an API. So it receives data, it has an input, and then it outputs data. So if you have like a jQuery plugin that has a callback, that is kind of an output. It's outputting data that you can then attach to. So we can do this much more cleanly using inputs and outputs. And then I put the little thing in quotes at the bottom. What role does your component play? So before even coding and going, oh yeah, we need a chat box, let's just start typing some stuff. Create some like diagrams that I did at the beginning, where you got chat, and then you define, okay, I need a chat search, I need the list of friends, and break it down into small components. Then you can then start designing your back-end APIs to then be able to tie into those components, render them, and then the front end, sort of the JavaScript, can then take the data, manipulate the data, and then pass it back up if you need to. So, Angular 2. Angular 2 kind of loves component architecture, so we're going to look at how we do this in Angular 2. We're going to look at bootstrapping, components, and shadow DOM. So if you're kind of into web components and the whole template elements and the craze behind that and Polymer project, you'll love that bit. We're going to look at how we do one-way data flow, property and event binding, and then some routing, and then I'm going to tell you some crazy stuff at the end, which I'm excited for it to land in stable Angular release. So the first thing we do when we bootstrap an Angular app is, right, there we go. If anybody wants to ask what this is that I'm using, I will tweet it afterwards because it's cool. So to actually set up an Angular app, we need, because we're using the router, the way that the router's coded, we need a base ref element. So we just put that to /. In, I think, IE9, that would break, but nobody cares. The next thing we need to do, this might look horrible for now, like you got Angular 2 polyfills, system.js, like what is system? I know when I started looking at Angular 2, I was like, what are all these things? Why can't I just include Angular 2.js and be happy? Then we're going to include TypeScript.js. Now, you wouldn't do this in production, but you can do it in development. What it essentially allows you to do is compile TypeScript in the browser, which is quite handy for quick demos and development. RxJS, the whole observables streams that we had the talk about yesterday. And then Angular2.dev, which is the development version. And then I've also included the router.dev. So you could include them all, or you could get system.js to load them. So this is system.js. It doesn't really look that pretty, but it's basically a module loader. So in, where is it, map. So I can say, have a look at my app. It's going to be .js files. I've got my main.ts, so that's where my main JavaScript or TypeScript file is going to be located. Then it will basically go and fetch all the modules. So you'll see I haven't actually included like script.js or anything underneath that. So system.js will go and get all those files for me. And then some people might go, oh my God, why are we rendering everything with JavaScript? Stay tuned. So literally the HTML looks like that, and then we've finished and we can push it to production. So we have a body tag and a custom element called app. Inside it we're going to put loading. If you're going to have a client that wants a production app, it's probably going to be more complex than that. So this kind of acts as a thing that you'll see before Angular loads. Then underneath we've got our bundle, which will be all the compiled JavaScript. And then system will basically go and grab all of those pieces. So how do we set up Angular? So keep an eye on the file names at the top. I've got main.ts, which is .typescript. Hooray for TypeScript. For those who don't know what TypeScript is, we basically have JavaScript, which is ES5, and then we have ES6, which is like a better version, a real language, and then we have TypeScript, which gives us like types. If you, from a back-end programming perspective, that will be more appealing to you to have types in JavaScript. Some of us hate it, some of us love it. It's completely up to you. I tend to write just ES6 code with TypeScript, but use like the decorators, which we'll see very shortly. So how do we do this? We import this thing called Bootstrap. It's not Twitter Bootstrap, don't panic. From Angular, and then we look at Platform Browser Dynamic. This is basically a package that allows us to bootstrap an Angular app in the browser, if you hadn't guessed. Then we import something called an app component, which could be like a root component. If you've ever tried React, you'll be going, OK, yeah, I get this. Then we call our bootstrap function, pass the component in, and it's done. Very simple. And just to recap, Bootstrap is how we like kickstart the application. So we need a root element, root component to do that. So we imported app component, but what does that actually look like? So Angular has this thing inside, which gives us an object or a function called component. We import that from Angular/core. Very easy. That's just ES6 import syntax. And then this looks kind of weird because it's got an at in front of it. So this is a TypeScript decorator. The Google team were working closely with TypeScript. They originally came up with something called @script. That got killed off because TypeScript finally implemented some stuff that the Angular team want. And then we have a class. So this is just an ES6 class called app component, and I'm just exporting it. So we have a file, we import component from Angular, we create something, we have a class, and we export the class. This app component thing is a decorator. So it basically ties to the ES6 class. So we have export class app component, and we have to place it on top. So it adds specific metadata to a class. It sounds fancy, it sounds complicated, it's not. It's literally just like a configuration. So here we say, I want a selector called app, and we pass in app. And if you remember in the index.html, we had the app element with loading inside. So that corresponds to this. So this creates the base element. Then we have a template inside a string. We all love strings. You can use template URL and go and fetch a HTML file if you want to. I kind of prefer leaving it in line. It's up to you. If they get massive components, move them out. It's a bit easier. And you'll see in the middle of the div class app, we have curly braces and then message. So this is Angular's interpolation strings. So Angular will basically look for data on the specific class called message, and it will go and basically inject that content into it. And that's as simple as it is. This.message inside the constructor, we do hello world, nice and easy. And that will basically render out a div with hello world in the middle. So now that we've got like a root component, how do we actually create like some more components? So we need to import other components. We're going to be sort of following along how we create the chat component and then the chat list, chat profile, chat search. We're not running these live. We're just using this cool scrolly thing. So we use import and then chat component. So if you imagine we've just created a base component called chat. We're using this. We're going to import it. Now, this is always a strange one with me, but this is necessary to use this directives array. I know it looks horrible, but it's basically because you need to inject it and register it within Angular's dependency injection system. If you've used Angular 1, you've probably created a mess, and it's so easy to create a mess. This is much more explicit. So just to run through that, we import the chat component. We basically tell the metadata that we want to use that chat component in the specific template, which, as you see, I've added like a main tag, which is just an HTML5 element. And then inside that, I've just put chat. So that's just going to inject our chat element or chat component in there. So before we continue, think about the stateless and stateful components. So these next pieces are going to be about that. So let's start with our chat component that we've just injected into app. That's going to be a stateful component. It's going to actually go and get some state. It doesn't in this slide, but it will do shortly. Don't be scared. So we import component, and you'll see on the next line, I've included this thing called view encapsulation. So if you're interested in like web components, this is your time to listen. So again, we create the component decorator on an ES6 class. We say I want to create an element called chat. We can then import chat profile. We can just import them and then go and create them afterwards. So we're going to import the profile, the search, and then the list. So we're going to then register those. We say I want to use these as child components of my chat element. We can then just declare them inside the template. So we've basically set up the structure. We've got the root component. It renders the chat element. Then we've got chat, which then renders chat profile, chat search, and chat list. So who hates inline styles? Nobody's going to admit it. 1, 2, 3. Come on, everyone hates it. So this is kind of an interesting thing, and I've had this debate on Twitter quite a lot. So people are like, why would you put styles on a component? And there's a really good reason for this. It's half to do with this guy, and it's half to do with something else. So I'll explain them both. So in the metadata, where we have @component, we can add another property called encapsulation. And we can just use that import object that we created and say view encapsulation.native. Now, if you're using a modern browser, that will actually go and use Shadow DOM when the browser can support it. Now, this is pretty cool. So you've got native Shadow DOM components. So Angular kind of sits on top of it. When you want to use it, you can use Shadow DOM. So these styles will actually be encapsulated to the particular component. If you wanted to change view encapsulation from native, like if you wanted to support a browser like IE9 in Angular 2 that doesn't support Shadow DOM, you can then say .emulated, which emulates Shadow DOM. It goes ahead and creates, on each of these elements, it will basically add an attribute that's dynamically generated. Then it will actually adjust your styles, so it'll be like .chat, brackets, and then the attribute name using an attribute selector. So those particular styles are encapsulated to that component. I'm not going to go into why encapsulation is cool, because there's a big argument online about web components and Shadow DOM. But that allows us to basically create native web components in Angular 2. The next piece, so we've kind of set up a base plate. We've got our component architecture in Flux, and then, not actual Flux, just in the works. And then we have the 3 child elements. We got a kind of a structure already. So we then talked about how we pass data from a particular service. We have the data we want to pass into a component. So this is pretty easy now that we've set this up. So we have a constructor. Now, this doesn't actually come from a back-end API. You can inject something called HTTP, which is an HTTP module. If you've used Angular 1, that's $HTTP. It's kind of the new version in Angular 2. So I just hard-coded this data. This could be from an API response, which would make it even easier, dynamic. So we've got a couple of properties, chat user, chat term, and chat friends. We're going to look at chat user just now. So it's got my name on it. It's just an object. We've got my name, which is a string, and then online is just a Boolean with the value of true. So then we have this high-level component with child components, and the high-level component contains all the data. Now, if you've created an app before, you've probably created a bunch of components, and then some of them will make XHR requests, and then you kind of got all these dependencies flying around, and you can't manage them. So having this high-level component, which goes and fetches the data as a stateful component, then we then pass the data down. So we do this via property binding. And you might be thinking, have you made a typo here with the square brackets around user? We'll come onto this and make a joke about how bad it looks afterwards. So what we do is basically take this.chat user. So I'll go back just so we can match it up. So we've got this.chat user. And then you'll see I've done in the string chat user. So Angular basically matches those pieces of data up, and then we can pass them into the component. Where we have the user, so it's just an attribute on the actual element itself. Now, we call these property binding. So this allows us to actually use native components, which we'll come on to at the end, like web components, bind to anything, basically. So we use square brackets to bind to data, bind data to a particular component. Then we can take this .chat term, which is just an empty string. So we don't want to actually provide a default value if somebody's going to type somebody's name in to then search for somebody. So we just leave it as an empty string. We can initialize it as an empty string. We can then pass the chat term in. And then we can have this .chat friends. I have 2 friends in my chats because I don't have any friends. So these are just an array of objects which we can then pass down into the chat friends component. In the chat list component, render them out. If we want to click on one, we can then send an event up. And again, we just use square brackets. We pass in that piece of data. So if you try and visualize this in your brain, you've got an app component. Then inside of that, you've got a chat component. Then inside of those, you then have 3 more components. And now the chat component is the stateful one, and it's passing it down into the stateless ones. Now you might be thinking, these 3 components do have state. They kind of take the state. They don't get the state or send the state off. They receive the state, they can manipulate it, and then pass it back. How we pass it back is through event binding. So we're still inside chat.component. But now we've created some functions. So if you can see the lines above that, we've still got this.chat user and chat term and chat friends. Underneath that, we've got on status change, on search change, and on contact select. So these are just completely made up methods. But if we were creating a chat component, these would probably be what we want. So let's look at on status change. This gets called when a user changes their status. So we want to know about this in the top level component. We don't want to handle all this stuff further down. So what we can do, we use some brackets this time instead of square brackets. We create a property called status change, and then we pass in a function called onStatusChange, which then takes an event. So we expect an event object back. So like we looked at earlier, data flows down, events flow up. So this is how we pass functions down that we can call in the child and pass that event data back up. Then we can take onSearchChange. So if the user starts looking for somebody to chat to, we can then filter that list. We can then get that event passed back with like a search term or something. I've put in here filtered collection. So this might be where we can run like a filter and send back the results that match. We can then do the same in here. We can bind it. And then on contact select, so if we've got a list of friends with a little picture and the last message that we sent to them, we can click on that. So that's like a contact select function. We want to know if that happens in the parent because we want to expose like another box with the chat window. And again, we just look into chat list, which we pass that function into. So we have all our chat with all the friends in, we pass all the data in, and then we pass the function in. Then the component does the isolated work and passes it back up. We're not going to run through all of these, but we will look at one of the examples of how we actually receive the data, manipulate it, and send it back. So, templating syntaxes. I tweeted this like a couple of weeks ago because it's kind of useful. We got square brackets and then like rounded brackets. So square brackets have property bindings, so when we want to inject data. And then I've used this think about my object. Obviously, you can use my object dot property, but if you want to look it up as a string value, you can, or dynamically, you use the square brackets. So when you come to remember these square brackets is property bindings, you're looking up something in an object. And then the round brackets are for events. So we can have like a click event or our own custom event. So we're going to actually create these. And then if you want to kind of think about events, they're kind of more function-y, like they do something. They pass a function down. So I put think my function, where you've got the little curly braces at the end. So I actually Googled this last night and then came up with this. This is legitimate. You can Google it. Don't do it now. So if you type Angular 2 syntax, you get this word ugly as the first result. Why might this be? Let's have a look at some crazy examples. So if you haven't looked at Angular 2 syntax, this is probably going to scare you and you'll think, why? So if you're coming from Angular 1, we had this thing called ngRepeat, which allows us to use something like a list element. We could pass an array of data to, and it would then repeat that list element for each piece of data. In Angular 2, we have ng4. So we have this, we have an asterisk here, we have like an uppercase F, and then we're declaring some JavaScript values in here. So when you think about like, why are we doing this in HTML? There's obviously two sides to this. There's the creating JavaScript in HTML, which is what we're doing, or there's the kind of React side where we write JavaScript to generate HTML. Like we can map over a collection and then return nodes. So another example is we have for two-way data binding. Two-way data binding allows for user input to change if from the browser. So if the user starts typing, the two-way data binding will then update a model somewhere else in the JavaScript. If the JavaScript model changes from like an API, it will then come back and then update the HTML. So it's this two-way cycle. So thinking about this in an input, we want to use square brackets. We want to bind. So we want to pass data to an input. And then we want an event, which allows us to then take the user input. So this one's taking it from the controller, or well, in Angular we had a controller, taking JavaScript input, binding the data to it, and then this is allowing us to have user input. So we can then update the text based on the event, which is what the user's typed for. Now this is kind of weird. They look like they're hugging each other. We have square brackets and then round brackets. So this is basically a shortcut for the above. So they're mutually exclusive, the same. I wanted to include this. I don't know why, I just felt like it. Oh yeah, let me mention Victor's blog. So I actually took these. Victor is on the Angular 2 team, and this is a huge post about how he explains the Angular 2 syntax. I would go and read this afterwards, if you like. So this is other syntaxes. These look familiar for now. ng4, this is like a collection loop. Then we have a model that we're binding, and then we can have an index so we can keep track of the current item in the collection. And then this basically, we call it desugar. So if we have a sugar syntax, it's kind of like a shortcut that looks nice for something more complicated. This can desugar down to this, which already looks a little bit more strange. So we now have this template, and then we're injecting a string. You wouldn't use these. You would use the sugared version. So I just wanted to include this just to show you the craziness that Angular is actually doing underneath that allows us to use things like web components. So when we're actually creating components like this, Angular is actually creating web components for us. So if you've used the web component spec, you have a template element. We used to have an element, I think, and some other stuff. So this is basically what, when we create like the directives that we bind to Angular templates, this is what it's doing underneath. I'm not even going to try and work out what that does without Googling it. So we had the search results that said it's ugly. Why is it ugly? So it allows us to bind to any native element, which is kind of cool. Like if you have like a jQuery plugin or even a React component, you would usually have to wrap that specific component in that particular framework, whereas you can take something like a date picker, for instance, and you can bind it directly to Angular without actually wrapping it in an Angular 2 component. So this gives us huge flexibility. We've got consistent syntax across all the code, and once you get your head around the template syntax with the square brackets and the round brackets, it actually makes sense. When I first looked at it, I was like, you guys are crazy. But once you kind of think properties for data and square bracket, I'm getting them mixed up, round brackets for events. So it gives you a consistent syntax across your teams. Now let's dive into stateless component. So we had the root component, which was app. We had the chat component, which was a stateful component. It went and fetched us some data, provides some data. Then we had a stateless component. So for this one, we're going to import component, input, output, and then event emitter. So but at the beginning, we looked at component architecture and how stateful and stateless components take inputs and outputs. They mutate the data. So we're going to have a template. We're going to use some inline styles again. Inline styles, by the way, are actually really cool. I was having this conversation with somebody yesterday or the day before, and we're sort of like, why would you put your component styles inline? So it was Harry, actually, at dinner. It was romantic. So what we basically do is, if you imagine just the frame or the shell of your application, so you can break that down like just purely presentational into like, I don't know, style.css. So you've got this small style.css with just layout related stuff. But then when it comes to components, because components are rendered on the fly and they're swapped in and out with views, we can conditionally show and hide them. It may make sense to paint them in line, and it has been, I think React team did some tests, and it's actually very, very, very fast. So if you imagine you've got a load of, from like a CSS perspective, if you've got, I don't know, 1 megabyte of CSS, you might have 100 kilobytes of that would just be purely presentational. The other 900 kilobyte would just be for components, and it's just wasted. So if we're changing views, we can then essentially compile CSS on the fly, and that ties in directly with the web components. When it comes to inputs, so let me flick back really quickly just to refresh your brains. So yeah, we had, if you look right at the top, actually, there we go. So we had square brackets, user, and then round brackets, status change. Let me go forward. User and status change. So these names are here. Input is user, and then the output is status change. So we kind of map the two together. So in here we have the template and everything, and then we have the ES6 class. And we've imported this thing called event emitter. So that actually allows us to then publish an event when something's changed. We then have a user status, and then a toggle status function if you wanted to just change your status. Obviously, we might have a more sophisticated example if you had like a drop-down list that says I'm away or offline. So this just allows you to change your status to be offline or online. Then this line of code here, line 42, allows us to basically publish that change. This uses an ES6 syntax for just shorthand. We want to create a property called user and with a variable called user. So the new object that we're actually publishing as a change is this one. So we're going to pass the name back. Nothing's probably changed here. And then we're going to pass online and then the new status. So we can pass the data down into the component, manipulate it, and pass it back up. Almost there. Routing and rooted components. So we looked at the three at the beginning. We had stateful, stateless, and then rooted. This allows us to basically import roots, which is like a decorator again in the Angular core. So what we'll do is import the inbox component, an inbox message component, and then a dashboard component. These are just completely made up that might fit in with our component. Then we can basically set up a routing, which allows us to route to these particular components. We can then inject something called router directives, where we have a router outlet, which is basically that view container. So we can have that view container where we can swap in these different components with different views. My time is up, so I'm going to fly. We can do server-side rendering, which we can basically render all this stuff on the server, even inline styles, all this kind of thing. Then Angular basically pick up where the server left off, rehydrate, we call it, sounds fancy, the DOM once it's finished. We can also run this in a web worker. Now, web worker's kind of not really talked about that much. We hear service worker and stuff. So if you've got this huge application thread in the UI, you can basically bootstrap Angular in a web worker, which is a separate processing core in the browser. We can do heavy manipulation of data in there, which completely frees up the UI thread. So the UI thread basically becomes lightning quick because it's not doing data processing, it's doing just DOM painting, which you've kind of got two threads, and Angular basically magically patches the middle. Service workers, we can cache stuff offline, everyone knows that. I'll post these slides after because I don't want to irritate anyone. Thank you for listening, really appreciate it. Thank you.